it's flickering. Let's see, what was my fix for that? All right, so let's get trucking here. So for today, we were supposed to, well, last class we looked at these primitive types given to us by the C programming language, as well as C++, as well as Java, as well as Swift, as well as C#. They're all pretty much the same primitives because all those languages are built on top of C. And let me actually quickly kind of give you that context. So if I look at sort of a history of programming languages here, let's call it programming languages that are modern enough that they have significant influence on our modern languages. The top of this list, we're going to have a language called C. And C, the type of language C is something called a procedural language. We'll be talking about what that means today. Off of C, we actually got two languages. We have a C++, and we have another language, Objective-C. And all of those were object-oriented. And if you want to add some labels to this, this is Microsoft, this is Apple. Needed to go from procedural to object-oriented languages, didn't agree with each other, so they were definitely going to go to different languages, just because. And we'll talk a little bit more about that. From C++, we went to Java. From Java, we took a little jog here and went to C#. All the way over here, we have a language called Swift. So I'm going to kind of label these columns a little bit. We're going to call this the Apple column. And this is the PC/everyone else column, more just the politics of technology when we had the split right here. Just giving you a little bit of background on this slide. So it's kind of a history context type thing. We're not going to go too deep into it because I want to get to the primitive type stuff here. But we'll try to capture all of it in 10 minutes or so. So historically, we had our a language called C, which is what we're going to use in here. That's a language for creating operating systems. We started seeing weaknesses in that language related to procedural programming languages versus object-oriented, which we will talk about. So punchline is we saw a need to go to object-oriented languages. So we did. Popular language at the time was C++. There was also another project called Objective-C, object-oriented C. Apple picked this guy. Microsoft picked this guy. Historically, Microsoft, Apple, not buddies. Roll back a little longer, they actually were friends. And then, there was some, stealing, yada, yada, yada. Really from everybody, because Apple got their graphical user interface operating system from Xerox. And then Microsoft at the time was working with Apple to provide their operating system because the early Apple computers ran on DOS, which is Microsoft's operating system, but not really, because Microsoft bought DOS from a kind of a hobbyist who wrote an operating system. They paid 50 grand for DOS, made a couple of bucks off of that. Kind of the interesting history lesson there is way back. Well, actually, so let me ask you this question. So we've all heard of Microsoft in here, right? Microsoft is no longer like the cool kid. Now they're kind of like the old technology stalwart. They've been there forever. What do you think Microsoft's most profitable business decision, or what do you think Microsoft is famous for? Maybe that's the better question. How did Microsoft make its money? Doing what? They revolutionized something with technology that at the time wasn't commonly done, and now Microsoft, it's their bread and butter. Go ahead. Not at the time, not internet browsing.
They sold their to IBM, but didn't tell them that they were going to sell to other people.
That's more of a business decision, but something with that deal with IBM. Microsoft said, we want to license our software to you. So Microsoft did not sell software. Even today, Microsoft doesn't sell software. Microsoft licensed software. So if you have if you have 5 computers at home, you have to have 5 licenses of Microsoft or be covered under their acceptable use for a single license, that kind of stuff, to use their operating system. So in this meeting, which he referenced, Steve Jobs and not Steve Jobs, Bill Gates and company was in a meeting with IBM. We've all heard of IBM. So IBM back then was like the Microsoft of today, sort of kind of the old fogey, no longer cool, but definitely like this industry leader type person. So they went to IBM. This was during the early days of consumer-based desktop computers, where people were actually starting to actually buy computers for their home, not just it being at big industry places. So they went to IBM and they said, oh, we want to, so this is IBM just starting to get into it. And IBM was a hardware company. And so IBM's like, well, you know, we're going to limp in to this market because it seems like people are starting to make money in this market. But IBM didn't want to overextend themselves, you know, so Microsoft effectively gave them a low risk way of doing this. Microsoft says, hey, you know what? Only when you sell one of your IBM PCs do you have to give us any money for the operating system, because we're going to license it on a per machine basis.
But they first went to Microsoft, then Microsoft told them to go to CPM. And CPM couldn't be bothered with them, so they went back to Microsoft.
Well, this is for the rationale that's coming up next. So Microsoft during this meeting ultimately made an agreement with IBM to license this operating system to them. And a famous quote from IBM at the time was, no problem, the real money's in the hardware. So at that point in time, Microsoft kind of invented this idea of licensing software, which sounds pretty good to a business like IBM, who says, oh, well, so you're saying I don't have to give you any money unless I sell a computer over here. Sounds like a pretty good gig, right? IBM's not taking any risk. They can still run the software that Microsoft is offering to license them. But the real kicker here was, and this was, let's call it the genius or the guts of Bill Gates, is he didn't have an operating system to license. So he just agreed to license something to IBM that he did not have. So once IBM agrees to this, then Microsoft has to go out and find an operating system to fulfill their end of the bargain. So they went and did that. They purchased DOS from a hobbyist. They've added to it over the years, and then obviously they started, you know, redoing the operating systems. But the early Apple computers were all running DOS, disk operating system, which was a Microsoft-owned product. And when Apple went to graphical user interfaces with a mouse, that was something they actually got from Xerox. Most of you heard of the company called Xerox. When you hear Xerox, what do you think? Printers, copy machines, that kind of stuff. Yeah, so back in the early days of home-based PCs, Xerox said, hey, you know what? We started dabbling in this home PC thing, but you know what? The real money's in copy machines. They've done all right, but they probably maybe would have done better just in home PCs. But regardless, they decided to discontinue their internal research and development on their own PC, which was a codename product called Xerox Star. And so they handed it to Apple. There was some sort of personal relationship between Steve Jobs and the Xerox people. So they let the Apple engineers come in. They basically handed everything over. So Apple's graphic user interface operating system was something that was given to them by Xerox. Microsoft then stole it-ish, which, you know, don't demonize Microsoft necessarily. All the big companies, these are just business decisions they make, right? I mean, even today, if you're a computer scientist and you write a piece of software in your basement and Microsoft wants it, is it better? Is Microsoft's, is it more efficient for Microsoft to steal your software and sell it as their own, then have you sue them and then pay you off? Or is it better for them to spend their time trying to write their own version of that software? Or is it better off for them to try to acquire you and waste some time? So they might go to you initially and say, hey, we want to buy your software. And you might say, oh, no, I think I have something great. Fine. Well, if you agree with them at first, then it at least looks more ethical, right? But if you say no, then what can Microsoft do? Well, they could just take it. They could take it, try to sell it. Then you get ticked off and you get a lawyer and you sue them and stuff like that. And, you know, it never makes the news or anything, because what happens? You know, Microsoft settles with you outside of court. They give you your $1, $2, $3, $4 million, whatever it is, you know, which is more than you probably would have made off that software, even if the software was really, really good. You know, you wrote it, you know, you weren't used to putting pants on. You wrote this in the basement of grandma's in grandma's basement. You didn't have the big marketing power of Microsoft to try to sell your software. So you probably weren't going to make $4 or $5 million on this thing, even if Microsoft can make $50 million on it. So the world still keeps turning, right? It's not, it doesn't sound ethical, but it's just kind of business practices with big companies. And sometimes the path of least resistance is steal it, pay them off, move on with life. I'm not saying that's a good thing, but it's a thing. All right. Well, OS2 was an IBM. Yeah. And that really just died. Yeah. So in any case, that was my tangent on where the Apple and Microsoft early relationship went sour, right? So hence the division between C++ and Objective-C. You also saw it in earlier Apple computers versus Microsoft computers, PC-based computers. PCs were very USB-centric, where Apple machines were, or Macs at the time, were FireWire-centric. So they couldn't even agree at the peripheral level. It just had to be different. Even today, the BIOSes in a Mac are EFI-based BIOSes. BIOSes in a PC are old-style BIOSes. Probably things are starting to trend towards EFI. But what's interesting is if you're on a Mac, you can install Windows natively on a Mac. All right. But because Microsoft doesn't check for some sort of special BIOS. If you're on a PC, you can't install the Mac OS natively on a PC. You can do some workaround stuff, but officially, conveniently, you can't install the Mac OS on a PC because it's looking for a very special kind of Mac certified BIOS, even though the stuff inside your computer is the same. We talked about a couple of classes ago about the idea of a compiler and how when you write software, it has to target the assembly language as well as the operating system, right? All right. Well, For an operating system itself, the code for an operating system can't target the operating system. So it's really just targeting the architecture. Well, today, until more recently, but for the last many years, Macs all ran Intel processors, just like your PCs do. So that means the architecture on both a Mac and a PC for a long time has been identical. So at that level, there's nothing that says the Mac OS shouldn't be able to run on, a Dell or a Hewlett Packard, something like that. At the architecture level, there were other protections put in that prevented the Mac OS, put in by Apple, that prevented the Mac OS from being installed natively on PCs. Now, why do you think Microsoft didn't put these same protections on Windows? So Apple put protections on their operating system so it wouldn't be able to conveniently be installed on an HP, presumably because they want you to buy a Mac, right? But why didn't Microsoft put the same protections on their operating system? Go ahead. Yeah, Microsoft doesn't make PCs. I mean, full-fledged computers. Oh yeah, make tablets, I guess. But generally speaking, Microsoft, like we mentioned a little bit ago, is in the business of licensing software. Heck, they don't care what computer you're running it on. It can be on an HP, it could be on a Mac. They don't care as long as they get their money. Well, that wouldn't make sense for them. So his question is, and we talked about this on the last class or class before about the M1 processors. So Apple has now transitioned to a new architecture based on their own chips, their own silicon. Well, Microsoft's operating system is not built, it's not compiled for that architecture. It's compiled for the Intel compatible architecture. So Microsoft could make the decision, well, am I going to have a version of Windows that runs natively on M1? Or do I just abandon that since there's already solutions? So for instance, on my Mac here, I can run Windows using a virtual machine. And that the virtual machine providers already have versions of that work on M1. So you technically can run Windows on a Mac that has an M1 through a virtual machine. It's already doable. It's just not running natively-ish, even though the virtual machines are getting better and better and better, where it's almost running pretty close to the hardware itself. But realistically, you're probably not going to see Microsoft go and create a version of Windows specifically for Mac. Because generally speaking, the people who are running Mac computers, a very, very, very high percentage of those users are not looking at running Windows on those machines at the same time. There was a time period where that was somewhat common, which is why Apple had that product called Boot Camp built into their operating system, because you had a big group of software that was only available on PC, on Windows, that wasn't available on the Mac. So you had business travelers and things like that who maybe wanted to have one machine that could kind of do both, depending on what software they had to open. But now most of that stuff, like for instance, Microsoft Office is on the Mac natively. It's on Windows natively. They're not exactly the same product, but they're compatible products. I would say a majority of Mac users today only use the Mac OS. The idea of, hey, you can run Windows 2 is more of like a gimmick if I wanted to. There's plenty of people today, probably some people sitting in this room, who are gamers who have a Mac laptop but have their PC gaming machine at home. You're not caring whether or not you can open a certain Word document or something like that on your laptop. You can today, but you have two different purposes. You have your school machine that, now that the prices have become somewhat competitive and the machines are pretty nice, you can get a Mac, but then your PC, nobody gets a Mac for gaming. That's just not the machine you buy for gaming. All right, so idea there is that Microsoft and Apple enemies for a long, long, long time. They drew the line in the sand even back here when they were splitting between, in the 80s when we were splitting between C++ and Objective C. Anybody know who the original maker of Java was? The company that actually originally made Java. Go ahead. It's Oracle today, but Oracle bought the company that made Java. Anybody know what that company was? McAfee, no. So even today, if you go to java.sun.com, it'll take you to Oracle's site. So Sun Microsystems was the name of the company that made Java. In fact, their ticker symbol on the stock market was Java. Problem is they never learned how to monetize Java. They put all their eggs in this basket of Java, which was actually a great product. Still is today, but Java probably would have died off if it wasn't for just a couple of very specific use cases for Java that just wouldn't let it die, specifically running full-fledged applications out of a web browser through these things called applets. And also Google kind of becoming a Java shop for a long time. They probably kept it afloat as well. But it was an interesting connection back to what I said a little bit ago about kind of these big companies. Again, Microsoft kind of becomes the demonized one in these stories just because they were the big fish for a long, long, long time. It's not so much that Microsoft is extra evil or anything, but Microsoft, they liked the Java programming language. Microsoft has a programming product called Visual Studio that has a collection of different programming languages in it. And they decided, hey, we like the Java language because Java is kind of C++ with a lot of the, we're going to say bad stuff from C++ taken out. We're going to be exploring some of that bad stuff this semester. It'll be kind of your frustration, but it'll make you appreciate Java next semester. C++ is still a great language. When I say bad stuff, it's more of things that allow a beginning programmer to get into trouble in that transition period when they're still learning what to do. You can almost maybe think of it kind of like if you're working in, with a construction or something and you have a table saw. It's kind of like a table saw without the security stuff that has like the shield and the thing that protects you from cutting a finger off, that kind of stuff. C++ is kind of like that. It's like, just use at your own risk type thing. So nothing innately wrong with it, but not necessarily the friendliest starting language from a debugging perspective, but does make you appreciate the more feature-rich languages that exist today. So in case Sun Microsystems came out with Java, Microsoft said, hey, we like Java. So Microsoft included a language inside of Visual Studio called J++. Sun Microsystems decided they didn't like that. Difference in our examples here is a little bit ago, I used the example of somebody writes some software in grandma's basement. Microsoft steals it, Microsoft sues them, they settle outside of court. Well, Sun Microsystems was a big company. I mean, they were a big server provider, so they were a hardware company, very similar to what Apple is like today. Sun Microsystems had their own version of Unix called Solaris. They had their own hardware called Spark chips with the processors they made, and they had Sun servers. So this was not just some kid writing software in grandma's basement. This is a big, big, big company in Silicon Valley. And they decided, no, we're not going to let Microsoft just pay us off. Sued Microsoft, yada, yada, yada. Microsoft lost, hence the invention of C#. Years and years and years ago, I was at this must have been in around 2000, 2001 maybe. Sounds, I think about right in that, maybe 99. There was a ACM conference at the University of Illinois in Urbana-Champaign that I was attending, and Microsoft had a booth there. And you always go to Microsoft's presentations at these things because they give away the best free stuff. Everybody else is giving away like bouncy balls and stuff like that. Microsoft, they were giving away boxed sets of Visual Studio 6.0. It was like a $600 software product, you know, and of course, all the computer science people, you know, we had already definitely legitimately purchased our copy. So we didn't need that wrapped copy that we can turn around and sell. So a very, very profitable booth, let's say. But what was very interesting, this was the first time C# was really like revealed. So there was somebody from Microsoft up there who was talking about this brand new language that Apple created, or sorry, that Microsoft created from the ground up. Best thing since sliced bread, yada, yada, yada. And he was basically describing Java up there. Now, having said that, you know, if you take a good programming language and you try to make it a little bit better, it's still going to look a lot like that previous language, right? So the Microsoft haters at the time might have said, hey, C#, you just duplicated Java, all this stuff. Look, they lost the lawsuit. They had to make something else. There's a whole lot of crap that Java did pretty well. Microsoft can then go and learn from that and say, hey, we're going to make a language that really duplicates that good stuff. We'll change the syntax enough that it's kind of a copy of what was on top of C++, not a direct copy of Java, presumably just enough that they don't get sued again, right? And C# is still today a super popular language. If you are a Windows.NET developer, you're writing your code in C#, very high percentage of the time. If you are a cross-platform developer who's writing stuff for Windows, for PC, for web, for Linux, whatever, you're probably writing your code in Java. If you are a Apple fanboy and you're writing all your software for either iPhone or the Mac OS, probably iPhone, you're writing in Swift, you know, which is actually another funny thing. If we look at kind of this family tree of our modern programming languages, they all came off of C, right? Now, what's interesting here is that for years and years and years, Objective-C was the Apple language. And to this day, it's probably among my favorite languages. It's a pretty cool language, has a little bit different syntax, and that won't make very much sense to us yet, but at some point you'll see me show some examples from Objective-C. But the punchline here is that nobody who was an Apple developer was complaining about Objective-C. There was no rationale for coming out with the Swift programming language for the Apple developers. The issue here is that iPhone's biggest competitor is who? Android, the Google people, right? If you're writing software natively for Android, what language do you use? This language. The Java programming language is the language that you use to write native Android applications. So even today, if you're a mobile app developer, you're probably going to make the most money writing software for iPhone, not Android. So even if you make the argument that there's roughly the same number of devices, or even if there's more Android devices in total out there, there's probably on average a more affluent group of people who are on iPhone, or people who are willing to spend more on the software, and there's more money on that side of things. But you still had a big group of developers over here on the Android side who said, hey, we're writing stuff for Android and we're used to writing code in Java. Well, so what did Apple do? They said, oh, we'll come out with this brand new language, trying to portray this as it's about time we took care of our developers who were not complaining. Swift looks a whole lot like this dude. Apple's basically saying, come over to the dark side, come write iPhone applications. Now we have a language that will look relatively friendly to you, rather than this old dinosaur that a lot of people maybe would have some trouble transitioning to, because there's an intimidation factor with Objective-C when you first start learning it. I still stand by my statement in here where I say programming is the skill set, the language does not matter. But visually, when you first see an Objective-C program versus a C++, a Java, C# program, right off the bat, there's a visual syntax difference that can be intimidating to the point that maybe you decide not to jump into the deep end of the pool. You might run away and go do something else, even though once you jump in, you realize that, oh, it's the same crap. Okay, so kind of an interesting thing that Apple did there with Swift. This is our latest, greatest. These are all our compiled programming languages we're looking at here.
So what is Fortran?
Fortran predates any of these things. It's a compiled programming language, doesn't support recursion, which is something we haven't talked about, but it would be C-based. But really for math applications, earlier days of computer processing. Yeah, but these are more general purpose programming languages. The other thing that Apple did, which is very Apple-like, which I think is ridiculous, is in Swift, they allowed you to name your variables with emojis. You know, and the joke I always make is, you know, you go back and you look at stuff from like ancient Egypt, right? And you have the hieroglyphics and we're trying to decipher the hieroglyphics. Then we go to natural languages, you know, for instance, like for us, for English, and now we're going back to hieroglyphics, trying to figure out what, you know, these string of emojis actually mean. So we fast forward, I don't know, a couple hundred years, that might be it. Our whole language would be based on emojis. So it's, I don't know, it's a thing, I guess. But I'm not necessarily I mean, I've written a bunch of stuff in Swift. It's fine. But I mean, if I were picking my favorite language in this group is probably Objective-C. Otherwise, really, any of these are kind of equivalents. You know, these two guys right here are really equivalents to each other. Java, C#, basically the same language. And you can think of these as basically being the same thing as C++, with just some extra safety features. You know, there are some conveniences added to them, but all of these languages are going to look a lot alike because they're all built on top of the idea of C. All right, so the stuff that we're going to be doing in this class using C and then some C++, when we jump over to Java next semester, 95% of it's already going to look familiar to you because a for loop written in Java is identical to a C++ or a C for loop. Literally identical, not close. You don't have to change anything. All right, so these languages are very, very closely related. All right, anything else I want to say about that stuff with our evolution of languages? We'll swing back in here some when we talk about object-oriented versus procedural, but let's kind of leave it at that for right now. All right, questions about any of that? Oh, sorry, go ahead. Python would be, I usually have kind of another column over here. I usually started off with like a language like Perl. And then as we go down here, we would have, this is actually a pretty good thing to add on. Let's see, we'll throw Python in here. We'll throw Ruby on here. I'll go ahead and throw Node.js on here. You can throw some other things as well. On the side over here, I'm going to put JavaScript. Now, JavaScript in and of itself is its own programming language, but because we typically use JavaScript to do the active dynamic side of web pages, we talked about that in here. It tends to be, all these languages tend to have strong connections to the web world in modern stuff. All of these languages are also interpreted languages. So a lot of times what I'll do is I'll kind of label this column as the native languages, and then this column as the web languages. Let's see what else I want to say in here. Yeah. Visual Basic's a little bit weird because that's a Microsoft language that ultimately compiles to an executable. but basic would be interpreted. Yeah. Well, for me, I'd say it's what's the right tool for the job. I mean, when I write software for Android, for Mac, for, in fact, actually, I would say I don't write very much software directly for the Mac, but I wrote a lot of, one of my software companies was completely based on iOS stuff. So I historically have written a lot of stuff for iPhone, but I write for all the platforms. The reason I used to argue for a Mac, a high-end Mac, was it's 2 machines for the price of like 1.7. Because you would have one machine with enough resources in it that you can run Windows on it, you can run Linux on it, all the different things. So you just had to carry around one thing that had all the tools you might need as a computer scientist. Apple's high end these days has gone up a little bit. I mean, this machine is a beast. So I mean, this machine is an awesome computer. Well, better is relative. I think I showed you my specs on this last class or the class before that. I run a lot of virtual machines. So this line right here, this 64 gigs of RAM is a big deal for me. And then I have a bunch of i9 processors. So that's 16 logical processors. So I can run 2 or 3 full-fledged operating systems on here, virtualized, but they'll feel like full speed machines all at the same time. Without feeling like I'm giving up much power. But that's, again, you know, my field is this. So this is, you know, my kind of like, if you're a farmer, you have your work truck, right? So this is that thing. So to ask the question, which is better, is all relative. I mean, my favorite machine, I only use this machine if I'm tethered to a power cable. Typically, I have decent battery life, but when I'm out and about, I go into a coffee shop, I bring my MacBook Air with me. And the only reason it happens to be a Mac is because of the form factor. And I think the M1, the Airs are priced pretty competitively. I don't think they're extra expensive computers, but I mean, this guy was like almost $6 grand. I mean, it's like ridiculous. So, I mean, if you're going off of a price point, get an HP, right? And I would even make the argument, if you're going to not write software on iPhone or Mac stuff, get a really beefy gaming laptop with a bunch of RAM. It'll cost you half the price of a similar spec Mac, and you could still run your virtual machine thing on it and run Linux and all that stuff. And if you really, really, really wanted to run Mac stuff, sometimes when there's a will, there's a way. There's a couple of projects out there that allow you to get Mac working on there. The argument I would still make, though, and again, I don't want to portray, I mean, this is kind of more of a Christian worldview thing. You shouldn't be just chasing the dollar. You know, I was definitely my most unhappy when I was making the most money. I can tell you that whole backstory at some point over lunch if you're interested. But computer science is a pretty good paying thing. That idea, when you're a poor student, $6 grand for a computer seems completely ridiculous. Like, you could get a pretty good car for that, right? At some point, though, that's going to be a drop in the bucket. You're not going to think about that kind of money. So your thought process goes through a different thing. I don't want to carry around 2 or 3 machines was something from a long time ago. Now everything's lightweight and things like that. But the idea of which is better is kind of out the window. You could do your whole computer science career on a MacBook Air or on if you bought a new HP laptop today, not necessarily a gaming one, really what you're paying for with a gaming one is the graphics card. But if you bought a pretty mid-end plus HP today, it would last you 4 years. You know, if you're trying to make the machine from 5 years ago kind of still last, you're probably going to run into RAM issues first. Where, you know, if you have a machine today that has less than 8 gigs of RAM, I would say you're on your last leg, or possibly kind of running along on like nubs. Even 8 gigs, I would say, is pretty low for a modern computer. So really, from a computer scientist perspective, a machine with at least 16 gigs of RAM is where you want to start. And if you're buying a computer right now, 32 gigs of RAM is what RAM's cheap. I'd one way or another get 32 gigs of RAM or more in that machine, and you'll just be set for a while. Is there another question? Go ahead. Well, that's a loaded question. Technically, you can run Mac OS Server, and they have much older versions of that, so it wouldn't be the latest, greatest version of that. And you can do that under the license. That was a lawsuit Apple lost. So let's just throw that out the window, pretend that's not a thing, since you would, I presume you mean you want to run a modern version of the Mac OS. You cannot do it legally. So let's throw that out there right off the bat. So officially, I'm saying this is something you probably shouldn't do. Running it in a virtual machine might actually be more difficult than running it natively on the hardware. There's a couple of projects out there for educational purposes, let's say. One of them is called Hackintosh. That allows you to kind of pull it off. But realistically, I'd almost make the argument now, and I said it a few minutes ago, that if you really have an interest in running Mac OS, I mean, I think Mac OS is the better operating system than Windows, but not because Apple made it, it's because it's based on Unix. I think Unix is the better operating system that's been around for a couple of minutes. But if you really have an interest in running Mac OS, just buy a Mac. The Macs today have come down in price enough that an entry-level Mac, which is going to feel plenty fast, isn't substantially more expensive than a similarly spec'd HP. It's once you start adding to the screen size and RAM and all this stuff, you start beefing it up to high spec. That's when Apple gets pretty ridiculous pretty quick. All right, other questions? Go ahead. Yeah, I'm about to get to it. Yep. So I guess what we'll cover here is one thing you run into in technology is we like to come up with fancy sounding words that make things sound way more complex than they are. And one thing that we're going to, oh, I'm actually missing a pretty important language in here. PHP. So this story is going to kind of cover the truth of web programming and how every single new technology that comes out today related to web just tries to do the exact same thing that we've been doing for a while in a tiny, tiny, tiny better way. So I'm not going to go into the details of this. I'm sure I'll cover it in some other class, or you'll see it in another class, or I'll get off on some tangent at some other time. But generally speaking, when you're writing web stuff, your user interface lives in the browser, and you're talking to another computer somewhere called a web server. And that computer is the one that actually runs your program. So if you're using PHP or Python or Ruby or Node.js, any of those, the browser knows how to execute JavaScript. That's like local stuff. You're using it to validate, making sure you filled in your username and your password before we try to send it to the server. So form validation stuff. But when you actually go to run your PHP or your Python or your Ruby code, it's running across the internet somewhere, or possibly if you have a test server set up on your computer, it's running on a server somewhere. And that server could be hardware based or it could be software based. But it's another computer-ish type thing that will run that program and ultimately output HTML and JavaScript, because that's what the web browser understands. So the output of any web-based program will be HTML and JavaScript every single time, because that's what's ultimately showing up on your screen, on your user interface that the user is using. So Perl was a language that predated the internet. When the internet first kind of became a popular thing, probably in 95, 96, that's when people started, trying to leverage these languages like C to process a web form. you know, to like log into a system or something like that. You would put in your username and password, hit submit. It would have to go to a computer program somewhere and process that. So early on, that was done through a language like C, maybe using an adapter, some other adapting technology. The early one was called CGI, Common Gateway Interface. Doesn't matter. It was basically just a little compatibility hookup that allowed a C program that was invented way before the internet to process web stuff. Okay, going through this little pipe. Well, then Perl was a pretty modern scripting language that a lot of Unix system administrators used. And in the early days, certainly even modernly, Unix tends to be one of the top server operating systems for running web servers. So the developers started saying, hey, what if I could use Perl to process my web forms and things like that? That was maybe a little bit more modern, and there was the ability to add some extra libraries into Perl more conveniently. So let's call it just an upgrade for web development over C, but still you were adapting an old technology to accomplish something newer. PHP, we're going to say, is our first programming language that was designed with the web in mind. It's still a general purpose programming language. It's still based on the concepts of C. It's still an interpreted language. It just has a lot of crap built into it that just knows about the web because it was created post the web. Okay. So PHP has a lot of that stuff built into it, but still the output of your PHP program for web development is HTML and JavaScript, because that's what plays inside of a web browser. All right. Python. Well, actually, let's just stick with PHP for a second. The problem with PHP, even today, this problem still exists. I'm kind of giving you the rationale of why do some of these other things come out. Specifically to your question, why did Ruby and Ruby on Rails come out? So even today, the problem with PHP is this. If you wanted to become a web developer today, if you wanted to use PHP, you not only have to have a computer programming skill set, you also have to have somewhat of an IT skill set, because in order to type in some code and have it execute using PHP, you would have to install your own web server on your computer with the PHP module and get that all up and running and things like that. So you can ultimately write your program that when you hit it from a web browser to test your program, you launch an HTML page, you click, put in username and password, hit submit. It goes to your local program. It goes to your local web server that you set up using your IT skills, and then runs that PHP thing. It required a greater skill set than just programming. Okay. Now, a lot of computer science folks come in with both of those skill sets, because maybe computers are both your chosen profession as well as maybe your hobby. You've done both things. So for me, I started programming when I was 9. I was always taking apart computers, putting them back together. So both of those skill sets were comfortable for me. I've done it since the beginning. My wife is a computer programmer, but that's where it begins and ends. It's her job. She could read the instructions and get a Wi-Fi router or something set up. It's not like she can't do it, but it's not an interest for her. She doesn't have a pre-existing skill set for it. So getting a web server and all that stuff installed would be an intimidating task for her, even though she actually does web development as her job. All right. She's been doing it for 20 plus years. She wouldn't want to deal with that side of things. She relies on the IT department at the place that she works to manage all that. Now, today, it's maybe a little bit less of a problem, because if you want to write PHP code, you can go to, there's some online, you can download something like WAMP or something like that and double click and installs, and you have a PHP development environment. Or you can create an account like GoDaddy.com, and that already supports PHP. So we have kind of an infrastructure that's built up around PHP, because it is such a popular web language that has taken a lot of that IT pressure off, so you didn't have to do it yourself. But there's a point of entry that's a little bit rough, because even if you went and signed up for an account with GoDaddy to do your PHP websites, now you still have to deal with the task of, okay, I'm going to write my code locally, then I'm going to upload it through FTP to get it up onto the web server. I need to put it into the right folder so that ultimately when I hit this domain name, it's running it. It's still a complex type of thing. All right. So even though I'd say it's better today than it was at this time period that drove his question, which I'm about to get to, PHP had that weakness. Great language, definitely built for the web first, but relied on an infrastructure that kind of required maybe either somebody else to set up for you or you to jump through some extra hoops to get your development environment set up to even start testing. So he asked about this programming language called Ruby, along with something that you really never in practice hear anybody talk about Ruby. You always hear them talk about Ruby on Rails. So I just mentioned a minute ago that the problem with PHP is the programming language, but it needs to run on a web server. And you have to get that web server set up. Ruby on Rails, Ruby is the language, Rails is the built-in web server. So when you download Ruby on Rails, it comes with everything. It installs a language and gives you a running web server. It also solves another problem based on this design pattern called MDC, which we'll talk about at some point. But the Rails server also has that built in. So Ruby really takes a lot of the problematic things that were in play with PHP. And it's not that the Ruby language is anything special related to PHP. In fact, I would say today, PHP is still the more popular language, especially since now we have a built up infrastructure compatible with PHP that's become very much commonplace. But in a time period there where Ruby became very popular, Twitter was originally written with Ruby on Rails. During that time period, we still had that entry point problem with PHP, and Ruby on Rails allowed you to have a single pod with your full development thing. You can have Ruby, you could talk to the web server. Rails also had built into it a database, so you didn't have to configure and install another database and teach PHP how to talk to it, any of that stuff. So this idea of Ruby on Rails, these are two technologies that were commonly used together and were immediately linked. There wasn't really much configuration. So Rails is the web server to Ruby being the programming language. Okay, so does that answer your question about Ruby on Rails? All right, so now some other things that you may have heard of before. How many of you have heard of something called Ajax? Okay, half a hand. What about jQuery? What about jQuery? There's a couple other ones, but I think we can leave it at just these. The problem we had with early websites was, and we can, although it wouldn't have updated very often for the Packers on Sunday, but let's think you're following sports scores or something like that. You go to a web page and you expect today that you don't have to keep hitting refresh on the page, right? The scores update in real time. Well, that is something that's very reliant on newer technologies. In the early days of web development, even though JavaScript already existed, the idea would be is if you had a little portion of the page that showed the current score of some game, that would not update until you hit refresh to refresh the browser. And even some of the early fixes to that, what it would do is you would have the website completely refresh. The entire website would refresh, meaning that any images that were in there had to reload and all that stuff. So it would be very slow, very noticeable. Where now, if you're loaded onto some web page that has a sports score on it, only that one little section of that page refreshes. And you don't even notice it really refresh. You just see the score change. All right. So Ajax was our first technology that allowed a portion of a web page to refresh. jQuery accomplished the exact same thing, but just better. Ajax was kind of a hack. It took the this original idea and say, okay, well, we just want to figure out how to make this happen somehow. And we're going to, just manipulate reality enough to make it happen. Where jQuery said, you know what, we can take this idea of a document object from JavaScript and we can rewrite portions of that and have just the page. So it's a much more organized way of doing it, but ultimately it's accomplishing the identical thing. Make sense? All right. But the funny thing is a lot of people look at these as being their own technologies. They're not. Ajax and jQuery, these are just JavaScript libraries. They're written in JavaScript. So it's just an extra JavaScript library that's using the exact same JavaScript that your web browser already supported. Just somebody wrote a bunch of code that uses that JavaScript to solve a hard problem. That's it. In fact, I would make the argument that today, almost any new technology that comes out for the web that involves what happens in the browser, some portion of the screen refreshing or something like that, is just syntactic sugar for something that's JavaScript. Under the hood is going to be a JavaScript technology that some smart person wrote a special library that does some newfangled thing to accomplish a task, but it's still at its heart JavaScript. All right. And that leads us to the last part here, where in web development, we kind of have two different groups of web developers. We have the front end developers. A lot of times these are more graphic designer type people with maybe let's call it some light programming skills, just enough to kind of write some JavaScript to do form validation, making sure you filled in all the buckets on your form. And then you have back end developers. The back end developers are probably more like your typical computer programming people, where you're not really worried too much about the look. You're more focused on automation. You have a computer program, it's going to take some inputs from a web form somewhere. You're going to run a program with a bunch of logic in it and stuff like that, and ultimately spit out HTML and JavaScript. All right. Now, because most websites, you wouldn't play the latest, greatest video game from within a website, right? That's just not kind of how websites are typically used. So we would say that if you go to 10 websites, probably 8 of them are very, very, very similar in terms of the problem they're actually solving, right? They have some different content on them, but a website, we kind of have an expectation of what websites are capable of. Every now and then you might go to a site that kind of seems like it's really pushing the envelope of what's possible on the web. So we'll call those the 20% outliers in this example. Okay, but the idea is that for web developers today, since commonly we're doing the same kinds of things, there's not a great reason for that hybrid skill set, the person who's kind of, because what I want to dissuade here is this idea that has been around for a while where, oh, you're a web developer, you're not a real programmer. The idea is that many web developers might not necessarily have a strong programming skill set, but some do. And that also doesn't mean you're not a real programmer, because I can just as easily make the argument that, well, most real programmers couldn't build a user interface for their life. It would work, but it wouldn't be usable. It would look ugly and not be functional and all this other stuff. So really, your average web developer probably has somewhat of a hybrid skill set where they're pretty good at both of those things. They're not so good at design that they can pass as a pure artist, right? But they're also, not so bad at design that they're a computer programmer. But they're good enough at programming that they can accomplish what they need to accomplish for their job, and maybe then some. So it's a pretty powerful skill set having both of those skills. And because of that, and also because you do have a percentage of those folks who have increasingly strong programming skills, because there's all sorts of resources out there for learning more and more programming, you probably have web developers who don't only care about the front end stuff. They're not just writing HTML and JavaScript, making things look pretty in the browser. They could also be in charge of the back end stuff, the PHP, the Python, the Ruby, those things. that make their web application actually work. Now, with that in mind, and this isn't necessarily to take away and say that they aren't capable of it, but if for years you've been writing code using HTML and JavaScript on the front end, there could be an advantage for you to be able to use that same language you're already very familiar with, JavaScript, for your backend development. And that's what Node.js does. Node.js allows you to write your back-end technology, the stuff that's actually processing your web requests, just like PHP, just like Python, just like Ruby. It's allowing you to write it in JavaScript, which is a language that you maybe are already used to. So historically, we would have had JavaScript on the front end, PHP on the back end, Python on the front end. I'm sorry, JavaScript on the front end, Python on the back end. JavaScript on the front end, Ruby on the back end. Well, now we have JavaScript on the front end and JavaScript on the back end. That's what Node.js has brought to the table. And then a couple of other upgraded features and things like that. But at the end of the day, it's a convenience. Programming has not drastically changed over the years. The types of problems that we're solving has not drastically changed over the years. The tools that are provided to the computer programmers is what has changed. And you can kind of think about this in like the context of, I think I've used the example of like a car, right? You know, you have, you go way, way, way back. You had to get outside and crank the engine and get it to start. Then you had fuel injected. Well, before that, you had to kind of, pre-pump the engine to get it to start. Then you had fuel injected. We had manual transmission, automatic transmission. All of these things are solving the same problem of let's drive a car, but they're doing it in more and more convenient ways. Programming language stuff is the same. We're still solving the same problem. We're ultimately telling a computer what to do. We just keep creating more and more power tools, conveniences for the developers to make our lives a little bit easier. All right, that makes sense? All right, so this covers the last 25 years of computer programming. Well, longer than that over this side. So this is the last 25 years of web programming. And then this goes back to the late 60s, what we talked about over here. All right, so that gets us up to date on computer programming languages. And then getting to the paper you wrote from our primitive data types. A byte, a short, an int, and a long, all of these guys hold whole numbers. The difference is the size of the whole numbers they can hold. This is an 8-bit value. This is a 16-bit value. This is a 32-bit value. This is a 64-bit value. All right, which ultimately means that a byte, because this is a signed value, bytes can hold negative numbers and positive numbers. We call that signed. A byte can hold the values between negative 128 to positive 127. A short can hold the values, here, let me make this maybe a colon. A short can hold the values negative 32,768 to positive 32,767. And one thing you're going to find here is this is roughly plus or minus 2 to the 7th power. This is roughly plus or minus 2 to the 15th power. You're using 1 bit to represent whether it's positive or negative. And that's actually done using a special thing called 2's complement, which is not something we're going to talk about in here. That's a 325 concept. But just in general, if a short is a 16-bit value, we're going to use one of those bits to keep track of whether it's going to be a positive number or a negative number. The other 15 bits go to the magnitude. How big is the value? That's the 2 to the 15th power. All right. Because of that thing I mentioned a second ago, that 2's complement thing, we technically can get one more value on the negative side. than on the positive side. That's why this negative number is a little bit, I guess technically since it's negative, it's a little bit smaller, but it's got one more value that we can represent on the negative side that we can on the positive side, because we technically had one more little ability to represent a unique value in 15 bits. 32-bit, this is negative 2.1 billion to positive 2.1 billion, which is roughly plus or minus 2 to the 31st power. This guy is negative, I think it's 9.2 quintillion. Positive, is it 9.2? 63rd, yep, 9.2. To positive 9.2 quintillion. It might also be quadrillion instead of quintillion. Big numbers. Okay, these are big numbers. So this is roughly plus or minus 2 to the 63rd power. That's how we got those values. All right, so let's talk about, and we're out at 12:50, right? So have time? Okay, perfect. Let's just talk about those top 4 things real quick. All of these types, these primitive types, byte, short, int, and long, these all hold the same kinds of values. It just holds them in more or less bit space. So representing them in more or less bits. Now, today, memory is very inexpensive. Let's go back and let's say in 1995, I added an extra 8 megabytes of RAM to my computer that already had 8 megabytes of RAM in it. How much do you think that costs? Now let's put this in context today. Let's convert what 8 megabytes is in terms of gigabytes. Because if you go out and buy a 4 gigabyte memory upgrade today, or an 8 gigabyte memory upgrade today, or a 16 gigabyte memory upgrade today, it's pretty cheap, right? 8 gigabyte stick is what, 25 bucks? It's cheap, not expensive. So how many gigabytes is 8 megabytes? That's 8 divided by 1024. So that's 0.0078. We'll just say 0.008. So really, 0.008 gigabytes of RAM. That's what I'm actually adding. 8/1000ths of a gigabyte. Okay, you think 200? You think this costs 250 bucks? Anybody higher or lower? You think lower?
Maybe.
Go ahead. 50 bucks? All right. Well, I'm just going to give you the answer for time. Cost $1,000. It's not adjusted for inflation. It would actually be worse. You know, so this was how much I actually spent in 1995. So today it would be, I don't know, probably close to $2,000 more. It'd be more expensive today. But even if we assume that inflation doesn't exist, for 8/1000ths of a gigabyte, I paid $1,000. Now, if we use our number, what does RAM cost today? I'm just going to go with that 8 gigabyte chip. It's $25. Is that kind of a fair number if you've ever upgraded RAM or something? Call that, that's ballparky. Okay, 8 gigabytes is $25. All right, so that means that 1 gigabyte is $3.15, $125. 1 gigabyte equals $3.125. But now I need 0.008 gigabytes. All right, so that's 2.5 cents. So that same amount of memory today would cost 2.5 cents. And I paid $1,000 for it in 1995. Oh, hold on, it gets worse. In 1995, price of memory had already started coming down pretty drastically. It used to be a lot worse. It used to be a lot worse. Okay, so is it fair to say that by today's standards, memory is pretty cheap? Yeah, it's no longer really our bottleneck. We have some other things that, heat and things like that, that might become bottlenecks for us when it comes to computers, but memory has become very cheap. But if I'm telling you in 1995 that it cost $1,000 and memory had already started to come way down in price, we could imagine from this slide here that in 1968, when C came out, was memory pretty expensive? Not only was it pretty expensive, it was pretty hard to come by. You didn't have computers with 8 megabytes of memory in 1970. Okay, you had bytes or low-end kilobytes. You maybe had a computer with 4 kilobytes of memory. You didn't have a whole lot of real estate, and the real estate you had was super expensive. So if you put yourself in the shoes of a developer back then, it might be pretty important that you have the flexibility to create variables that only used as much memory as you actually needed to hold your values. If you only needed to hold the numbers between 1 and 10, you never had a value above 10, you would purposely choose a byte because it was the smallest footprint of memory that you could use in the C programming language. You wouldn't just arbitrarily, in today's world, we would just create an int. It's like, I'm only going to hold a 10 in there, but I'll use 32 bits to hold that. No problem. Well, it's pretty wasteful, but who cares? We got tons of memory today. Now, that problem does go upside down eventually for very, for specific applications, some big scientific simulation or something. You might run into a situation where you would run out of computer memory. Okay, but generally speaking, relatively speaking, to the 70s and the 80s and the 90s, memory is dirt cheap today. We don't really think about it that much as a programmer. Okay, and where this was mostly seen for us was with the Y2K problem. How many of you have heard of the Y2K problem? Okay, the Y2K problem, the Y2K bug, was when we had a bunch of computer programs that had chosen to use represent the year as 2 digits. So now when we got to the year 2000, your computer program, especially for sorting things in ascending or descending order, couldn't tell the difference between the year 2000 and the year 1900. Those were the same year. So we had to go and we had to upgrade all of this software leading up to it. They were talking about it being the end of the world, and all the power grids were going to go off. I actually remember sitting there on the couch, and they actually had this, when now you watch, the ball drop in New York City or whatever, and maybe you catch it in Australia too, just to see what the party looks like. They were actually going from time zone to time zone. You were looking at some, podunk place in Madagascar or something, just watching what was going to happen to. They just had a camera on the power grid, like, whether the lights turned off. It ended up being basically a nothing burger. They solved the problem leading up to it. But the reason why all that old software was written with 2-digit years instead of 4-digit years was for this reason: how expensive memory used to be. That was the rationale. All right, on Thursday, we'll come back and we're gonna start here, talk about Unicode. What about 2038? Shouldn't be related to bits and bytes and stuff. 2048, I can see that's a power of 2, so that could have something, but I'm not familiar with it. What's up?
I want to move on today, and then also, the help that you did, like that, and I was trying to, you know, and not where you have